Hey, makers, thinkers and IoT dreamers! Welcome to the IoT Forge News Digest. I'm Pavel Koshinov, it's Tuesday, July 22nd, 2025, and this is episode 14. Buckle up, we've got gadgets, glue code, and a Goldfish-Driven car coming up next. Let's roll! I'd like to open today's episode with a gadget that's stirred up a pretty lively debate inside our community. The Comma 3X. In a nutshell, it's a little box you stick on the windshield that gives your car Tesla-style line keeping and adaptive cruise control, all powered by the open-source software AUTOPILOT. It already supports well over 300 different car models, from everyday brands to some more niche ones. Inside the hardware, you get three 1080p HDR cameras with impressive 140 dB of dynamic range, so they can handle bright sun, deep shadows, and oncoming headlights at night. Two cameras to watch the road, and one night vision camera to see inside the car. Driving it all, the Qualcomm Snapdragon 845, the chip you can find in Google Pixel 3 and Samsung Galaxy S9. Pretty old, but still plenty fast to run real-time computer vision models. You also get stereo mix and speakers for voice prompts and alerts. The 3X talks to your car over CAN, and it now supports CAN FD out of the box, so on modern platforms you don't need a separate adapter. LTE, Wi-Fi and high precision GPS are built in for data, updates and telemetry. Up front is a 6-inch OLED display, and onboard storage is 128 GB, so it can record drives and training data for the neural net. Inside the community, the big question was, AUTOPILOT's main model ran at about 20 Hz, a new prediction every 50 milliseconds. Is that really fast enough for reliable driver assistant on the highway? Let's sanity check it. At 60 mph, a car travels roughly 4 feet every 50 milliseconds. For lane keeping, that resolution is usually fine. Lane lines don't jump that far in one frame. Where you'll feel the limit is a sudden cut-ins and very high-speed maneuvers. In those edge cases, faster loops or a predictive model can smooth out the reaction. Crucially, 20 Hz is a perception update rate. The car's actuators, like power steering and brake controllers, still run on their own internal loops at much higher frequencies. AUTOPILOT just hands them command that those subsystems then interpolate and filter. Is it actually fast? For context, safety studies shown up average driver typically needs about 1 full second, sometimes up to 1.5 seconds, to notice a hazard and start reacting, like moving a foot to a brake, turn the wheel. And if the driver was briefly distracted, MIT research found hazard recognition alone can take half of the second, even before any physical movement begins. So, while AUTOPILOT is crunching the second 20 times a second, the average human gets only one shot, maybe less, within that same time frame. That doesn't make the assistance system perfect, but it gives you a feel for why 20 Hz is generally considering fast enough for today's level 2 driver assistance. So, Comma 3X is a relatively affordable step up to advanced driver assistance. 3 HDR cameras, a capable chip, modern vehicle bus support, and a big roster of compatible cars. It won't turn you right into a self-driver, but it will help manage speed and lane position, easing fatigue on long trips, as long as you stay in the loop and keep your hands, eyes and brain engaged. In our previous episode, we talked about the release of the Raspberry Pi Radio Model 2, a compact $4 solution that makes it easy to add wireless connectivity to your custom hardware without going through a full certification process. But there is another path, using an ESP32 chip. The latest ESPHome release introduced support for ESP-hosted MCU, an open-source solution from Espressif that turns any of their chips, ESP32C and S series, into a wireless coprocessor. This allows you to add Wi-Fi and Bluetooth to a host microcontroller that lacks them, or can spare the cycles to run a full network stack without giving up the ESP chip, GPIOs, or peripherals. So when would you actually need this setup? The answer lies in timing-critical applications. If your system needs to respond within milliseconds, handling network stack directly on the MCU can cause problems. Wi-Fi and Bluetooth interrupts may steal CPU time for hundreds of milliseconds, too much for real-time use cases. That's when pairing your main MCU, like STM32 or Tensy 4.1 with an ARM Cortex-M7, with an ESP32-based wireless coprocessor makes sense. Offload the connectivity and let the main controller focus on things like real-time 3D graphical user interface rendering, or local DSP for audio synthesis or multi-voice speech, even lightweight machine learning model like TensorFlow Lite with the 46-bit floating point support. It's a clever division of labor that keeps your system responsive, modular, and scalable. Or if you're deploying models on the MAX78002 from analog devices and in need of adding wireless support to this chip. Analog Devices has introduced AutoML for Embedded, an open-source Visual Studio Code plugin co-developed with AuntMicro. It's part of the CodeFusion Studio environment and is specifically designed to streamline the development of machine learning models for microcontrollers and other resource-constrained embedded platforms. Designing AI for embedded system is notoriously complex. Memory and compute limitations make it hard to deploy models, and tailoring an ML architecture for specific chip often requires deep domain expertise, from model selection and compression to quantization. AutoML for Embedded tackles this challenge heads-on by automating the entire ML pipeline. It stays fully open source and hardware agnostic, giving developers the freedom to focus on logic and application rather than wrestling with low-level optimization. Unlike traditional ML workflows, which are time-consuming and require manual fine-tuning, AutoML handles architecture search, optimization, and deployment adaptation automatically. The tool integrates tightly with CodeFusion Studio and already supports ADI's MAX78002 and MAX32609 MCUs. Now available on the Visual Studio Code Marketplace and GitHub, AutoML for Embedded provides a flexible, scalable solution to bring edge AI from proof of concept to real-world production faster than ever. An experimental library called tinymcp has been introduced by Goliath, aiming to bridge the gap between microcontrollers and large language models. It brings support for the Model Context Protocol to even the most resource-constrained devices, enabling them to interact with LLMs and, by extension, bring AI-driven control into the physical world. At its core, tinymcp is built around two key components from Goliath: Goliath LightDB state, used to track and think the state of connected devices, and Goliath RPC, used for triggering remote procedure calls on those devices. The library acts as a lightweight proxy server. It receives commands from the LLM in JSON RPC format, converts them into Goliath RPC calls to trigger devices, and returns the result back to the LLM. This setup makes it possible to trigger real-world actions like turning on LED via voice prompt or a simple natural language instruction from an AI assistant. tinymcp registers microcontroller functions like light on or light off as callable tools accessible to an LLM, enables the usage of Goliath as a communication backbone between cloud and hardware, and automatically publish a tool description using the MCP format, so the LLM knows what it can invoke and how. The project is still under active development, with upcoming features including support for multi-device orchestration, more flexible calls routine logic, and easier integration with various LLM APIs and interfaces. This is a meaningful step toward unlocking AI-driven automation in embedded system, without the overhead of deploying complex cloud or edge infrastructure. It turns microcontrollers from passive peripherals into interactive agents that LLMs can command and coordinate directly. And to wrap things up, let's talk about one of the coolest events on the maker's calendar, Open Source 2025. If you haven't heard of it before, Open Source is a massive celebration of open source hardware, indie inventors, bizarre robots, and hacker culture, hosted right in the heart of the Bay Area. Two of our editors had the chance to attend this year's event, and while they're still uploading gigabytes of video and scribbling notes, we've got an early look at Huckster.io's picks from the show floor, like Tic-Tac-Toe AI board, a fresh take on the classic game with a twist of strategic limitations, or Compass CNC, a handheld CNC router with screen-guided accuracy, coming to marketplace later this year. Fishmobile, yes, it's real, a goldfish piloting a wheeled vehicle using a Raspberry Pi and camera vision. Self-balancing backpack, a compact metal cutting CNC, and the 1000 key keyboard, a wall-side symphony of tackled switches. Not ergonomic? Totally awesome. We'll have a full recap coming soon, with behind-the-scenes stories, photos, and first-hand impressions from our editors, so make sure you are subscribed. And hey, if you missed open source this time, no worries, start planning now for 2026, because if you love open hardware, experimental builds, or just want to be awed by the raw creativity of the maker world, this is the place to be. That's a wrap for episode 14. If something sparked your imagination, share this pod with dead friends who need a 1000 key keyboard. Until next time, keep soldering, stay curious, and build boldly.